many, but I see only people I haven't seen before in this pavilion, and that's nice. That's a good sign. And it's also important to know, so we are streamlining live. So even if you leave earlier, or if you want to re-listen to some part, it's recorded and it's available on YouTube. And we will also recycle some of the material. So a warm welcome to our Concrete Future pavilion. And if you're interested in understanding our industry and our members' action, there is a progress report that is available there. And I want to fit, so our industry, cement is an essential building material, but we are responsible for 7% of CO2 emissions. Yes, and our industry has made a commitment to get this down to 0. So it's a strong commitment from our members, companies from around the world. And to achieve that, we have made a roadmap. And we have, over the course of the week, been looking at the different levers in this roadmap. And actually today, we are really focusing on what falls under for us savings in clinker production. So it's about energy efficiency and fossil fuel substitution. And our industry is very particular because we can actually deal, and we will hear this more in details. We have some experts to explain this, why processing waste in a cement kiln is a safe waste management solution, which not only deals in a safe way with the waste, but also at the same time reduces CO2 emissions. And so to illustrate this, we have Corey Carstensen from Sintef. He has been working on this for years, and he will explain to us what's the magnitude of the non-recyclable plastic waste problem. He will introduce us to the OPTOCE project, and then show how it has been showcased in different countries in the cement industry. And then I will take over, say a little bit more about what our industry does. And then we want to make an interesting link to another initiative with Adriana Bandi, with Lead Waste Climate Champion. And Adriana will explain another initiative, which is how to eliminate open waste burning in Africa. And then we will also discuss in a small panel afterwards how the two initiatives can better link together in Africa. So without further ado, I'm going to your presentation now. And I think I'm in there. Yeah. That's a magic, right? I don't know how I did this, but I'm impressed by myself.
Thank you, Claude, for the introduction, and good afternoon to everyone. It's a pleasure to be here. It's a pleasure for me to introduce you to this opportunity, using cement industry to get simultaneously rid of plastic waste, which is a problem, as you will see very soon, but also an opportunity, you know, and I will come back to that. So, you saw on the agenda, Claude, I was supposed to talk about 3 points. I have integrated these in one presentation, so I will cover everything. Just a quick word about Sintef. It's a foundation for scientific and industrial research in Norway, one of the largest in Europe, and we deal with basically technical and scientific and industrial research for governments, industry, etc. You probably know that we have been producing plastic since the 1950s. More than 9 billion tons has been produced. Out of that, more than 6.3 billion tons has ended up becoming a waste, whereas only 9% has been recycled, 12% approximately incinerated, and almost 80% can be found in dump sites and landfills and in the environment today. And that is causing a huge problem. Plastic recycling has been touted as a solution for plastic pollution crisis, but unfortunately there is a lot of new evidence showing that there are problems with recycling, especially that we can find numerous hazardous chemicals in recycled pellets. There was a study, I will come back to that. Apart from that, there are, of course, potential challenges with collection, segregation, polymer group restrictions, low economic values in many countries, and as I mentioned, now showing up to be containing a lot of hazardous chemicals. And that's, of course, unfortunate because recycling has been seen as the solution to the plastic pollution crisis. But as we have seen now recently, toxic chemicals can be found in recycling industry. And this shows you some photos and videos which has been taken recently. And there is no doubt, actually, and there is no surprise to understand that these recycled products contain a lot of hazardous chemicals when you see how it's done. This is a list of the recent publication. It was published only 2 weeks ago, I think, or even less. And it shows you that pellets from numerous countries around the world contain up to 162 different pesticides and biocides, pharmaceutical, even PCBs. So more than 600 hazardous compounds was found in plastic pellets in recycled products. And as I mentioned, that might not be a surprise when you look into how recycling is happening in practice around the world. They receive large amounts of plastic waste in, in some of these countries. It has to be washed. You have to remove inks and glues and things like that. Shredded, then you have to heat it again, melt it and cool it again, and pelletize it, and then send it for the purpose of shaping new products like bottles, for example, PET bottles or other products. But as we see, all these photos are taken only the last 3 weeks, so it's very recent. And this photo is from North Vietnam, and it shows this is a typical recycling village. And they import plastic waste from everywhere, which is possible. And they do recycling businesses, and a lot of non-recyclable plastic waste is generated. And as you can see, it's left in the environment, and the leftover is burnt or dumped into dump sites. So you can imagine the pollution caused by the open burning, of course, and the release and leach it into the rivers, etc., and the environment. And we have estimated that more than 5 billion tons of plastic waste can be today found in dump sites and landfills around the world. More than 5 billion tons. And in these dump sites and landfills, it will slowly break down into microplastic, and it will constitute a continuous source of microplastic to our oceans in the foreseeable future. It will be a never-ending story if it's not dealt with. In addition, there has been published recently a lot of new research findings showing that microplastic in the nature, even in sediments, are actually creating methane and CO2. So it's degraded, which is, of course, not strange to explain, but that it actually releases methane and CO2 is something new. And here you see some graphs. I'm not going into the details. It's just to showcase. These are recent research, and it shows that there is a huge potential of cleaning up waste, and especially microplastic, of course. In addition to the hidden amount of more than 5 billion tons that we can find in dump sites, there are millions of tons of plastic waste which leaks into the oceans every year through drainage from everyday life, from land-based activities. And there are, estimates saying that if we don't do anything with this, there will be more plastic in the ocean than fish in a couple of decades. And as we all know, microplastic in the ocean constitute a serious threat to biodiversity, economy, and even our own health. Recent studies have shown that we can find microplastic in our blood, in the veins, and in organs. It lodges, and we really don't know the impact and the consequences of being full of microplastic in the future. And in addition to that, there are evidence that plastic contains a lot of chemicals which are also harming biodiversity and biota in different ways, in addition. And UNEP recently published a study on chemicals in plastic, which is worth reading. And there is also a lot of new research. This is also released only a couple of weeks ago, showing the effects of the chemicals in microplastic. Not the microplastic itself, but the chemicals which are leached out of the microplastic is impacting and harming biota in different studies. So there is no doubt we need to improve the treatment of plastic waste urgently. The primary contributors to plastic litter in the ocean stems from inadequate waste treatment capacity and infrastructure, particularly associated with major global river basins, landfills, and industrial sites. This is also taken last week in Mumbai, and as you can, this is a typical channel, unfortunately. And you see some people try to make their living out of finding recyclable items, which is of course very unfortunate. On the beach, we have Christmas trees in the mangroves, which are covered with plastic. And yeah. And there was another article published only also a few weeks ago, saying that one urgent measure would be a global, fully fledged, efficient waste collection, management, recycling, and environmentally sound disposal system that would guarantee an almost zero plastic release to the environment. So I think this is, of course, the goal and the end of our journey and all our efforts. But it's going to be very difficult, as it says further. However, this seems a financially challenging and possibly decades-long endeavor. Moreover, while such infrastructure could be economically feasible in industrial countries, it may not be feasible or cost-effective for developing nations. So, I mean, having this in perspective, I will now continue to try to look into some solutions, okay? We started this project called Ocean Plastic Turn into an Opportunity in Circular Economy, or short, OPTOCE, a few years back. It's funded by the Norwegian government under a big program targeting microplastic and plastic pollution in the seas. And we aim to explore the involvement of the cement industry and to assess how it can enhance the treatment capacity for non-recyclable plastic waste in China, India, Myanmar, Thailand, and Vietnam. And of course, the overarching goal is to contribute to the reduction of microplastic release to the sea. I mentioned 5 countries. I would say that this is a super important region. They have a population of almost 3 billion people. Half live in the coastal areas, and they have amongst the highest plastic waste production in the world today. They produce stunningly 217,000 tons of plastic waste every day. 217,000 tons every day. And they have one thing in common. They all lack in, waste management infrastructure and treatment capacity. So a lot of the plastic waste is ending where it should not be ending. On the other side, there are some opportunities. These 5 countries is also the most industrial region in the world. They produce 75% of the world's cement, 75% of the world's steel, and 75% of the power of the world in tens of thousands of plants, which are using huge amount of coal, as you may know, and of course contributing with a large chunk of the world's CO2. So here we have a clue for a possible solution. Because if you can replace some of the coal with non-recyclable plastic waste, which is fossil fuel based, of course, then it might constitute a win-win solution. That's what this project is about. And it started in Norway long time back. We started to use our cement kilns in Norway more than 30 years ago. And it has been the only disposal solution for organic hazardous waste. And the reason is that cement kilns has a very high temperature, long residence time, surplus oxygen, etc., which are ideal to destroy organic hazardous waste. And Norway chose not to build any incinerator, but only to use its cement industry to dispose of its organic hazardous waste. And this has, of course, led the cement industry into a journey. And today, the cement industry in Norway is replacing more than 75% of its coal with waste, which needs to be treated in some way or another anyway. You can incinerate it, or you can landfill it. They choose to use it as a coal fuel and coal replacement in cement production. And more than 75%. And this is called thermal substitution rate. If you go to Asia, this is also, the concept is called co-processing. And it's an integrated waste management option, which is available around the world today. If you go to Asia, you will see that the TSR, thermal substitution rate in the cement industry, is in average around 3%. Meaning that only 3% of the coal is replaced with various waste, also plastic waste. It means that there is a huge potential of utilizing cement industry to dispose of waste, to save coal, and reduce its emissions. And this is something we are trying to do in our project. Let me just mention a few of the benefits of co-processing in the cement industry. The cement industry is already there in all these 5 countries. It operates 24/7, 365, almost 365. You don't need to build any new facility. It has a very large treatment capacity compared to, for example, municipal solid waste incinerators. It's a complete and final disposal solution. There are no liabilities connected to treatment in the cement industry, as, for example, you will have in a landfill, which I will show you later. This practice does not produce any residues. There are no fly ash, no slag, nothing. Everything is integrated in the final product and is decomposed. It's high temperature inside the kiln. It's up to 2000 degrees in the gas phase inside the kiln. Make sure that every hazardous chemical is destroyed safely. Emissions of doing co-processing is normally unaffected by taking waste. And if you do this in a responsible manner, which we assume it is, the energy recovery is very efficient by utilizing this methodology compared to, for example, waste incineration and electricity production. It reduces the coal and raw material consumption. It reduces CO2 compared to incinerators and landfills, of course. And very important, it's usually cost efficient. And we see that all over the world today, that when the cement industry starts to co-process, they can compete with other traditional waste management options effectively. But there are critics towards this practice. There was an article, it was a book actually, published a couple of years back by Reuters, and where they are citing, for example, a retired professor in environmental chemistry and toxicology in New York University, saying that plastic releases harmful substances like dioxins and furanes when burned. And this is, of course, very important to investigate if this is true. And I will come back to that when I show you the results of our project, what we have achieved. In our project, we are carrying out pilot demonstrations which compare the technical and environmental performance under baseline coal-only conditions with co-processing conditions where various sources and amounts of non-recyclable plastic waste are used as a co-fuel together with coal. And we are going to provide independent performance verification, and all the results that we produce are published in technical and scientific literature, peer-reviewed. You also may know that there is a global agreement for plastic pollution is underway under UNEP, and more than 190 nations have agreed to produce this agreement next year. Hopefully it will come next year. Our project aims to provide the premises for disposal options for non-recyclable plastic waste and to support science-based policy and decision-making, especially in, of course, emerging economies and developing nations. Now I will come to the results of the project up to now. We have tackled 4 main sources of large volume non-recyclable plastic waste, and to test it in local cement kilns in all the countries that I mentioned. And that is plastic from dump sites and landfills, it's plastic from large rivers, plastic from large industry, and plastic from plastic collection and recycling activities in big cities and municipalities, which always produce a lot of non-recyclable plastic waste. Starting with China. We have done several pilots in China. They produce almost 50 million tons of plastic waste every year. And our effort started in the Yangtze River, which is one of the biggest in Asia. And it brings millions of cubic meter with floating material during the rainy season, downwards into the South China Sea. This is clogging, for example, and stopping at big dams on the way in the river. This is from the biggest dam in the world called Three Gorge Dam. And here the authorities have to remove the floating material. If not, it's damaging the turbines. So it has to be removed. This is the dam. And here you see a video showing how they have to collect this. This is done 24/7 during the rainy season, 6 to 8 months a year. They have to collect this floating material and take it away from the dam. And what happens with the floating material is dumped, of course, basically. Yeah, you can see, see the magnitude of the problem. So they are using excavators and collecting this. This is the dam authorities. We took it to upstream cement plant and used it as a co-fuel in their cement production. And here you see the location in the Hubei province. And this is the cement plant. It's a state-of-the-art BAT and BEP cement plant. And here you see floating material taken up from the river and some way dewatered as it's waiting for disposal. And here you see the plastic content. In the floating material contains everything. Between 13 and 20% of plastic was identified in the samples. And we were feeding around 13 tons per hour in this particular cement plant. We were also testing municipal solid waste, which were diverted and produced into what we call refused oil fuel from a nearby city, just to investigate, because they had a big problem with municipal solid waste in the city, and we wanted to see and showcase if it's possible also to take that waste stream. And here you see this is raw MSW, and it's converted slowly into what we call RDF, refused oil fuel. And it contains between 12 and 20% plastic. And when it's fed to the kiln, it's almost dry, or 10-15% humidity, comparing with 60-70% at the beginning. And feeding into the plant, and here you see, this is just show you some average figures of the dioxin emissions from this particular plant. And the straight line, the blue line here, is actually showing you the 0.1 nanogram TEQ per normal cubic meter, which is the international standard in most countries today, and is the most stringent emission standard anywhere. And they pass whatever we feed from the floating material, MSW, etc. It has no problem of complying with the emission limit value for dioxins. Remember the retired professor that I mentioned to you? So this is only one of many, many plants along this Yangtze River. And they will take more than 150,000 tons of floating material and RDF annually. And they will ensure that at least 20,000 tons of plastic is avoided to, ending in the South China Sea. And at the same time, they save at least the same amount of coal, 20,000 tons coal. So I would consider that to be a win-win story. During the outbreak of COVID, you remember, I guess you all remember very well, in February 2020, in Wuhan, all the scary stories coming out of Wuhan. And we were collaborating with our partner in Wuhan and in China at that time. And during the outbreak, the hospital waste generation rose by 600%. And the government of Wuhan didn't know how to deal with these plastic, especially the plastic waste containing, low infectious plastic waste. So actually we took the use of cement kilns around Wuhan, and the biggest volume actually constituted low infectious plastic waste like face masks, gloves, shields, etc., as you can imagine. And during a few weeks in the mid of the outbreak, these 4 kilns were actually taking more than 170,000 kilo of low infectious COVID-19 waste and avoided a crisis, I would say. So the plastic waste entered into the cement kilns in plastic boxes wrapped in plastic bags. Every step was disinfected, of course. Everyone was concerned. And more than 20,000 packages were fed into the kiln inlet during daytime only during this operation. And as I mentioned, everything we do is published in international journals, and you can find it and you can look it up and read it for yourself, the details. Okay, let's go to Vietnam. In Vietnam, they produce almost 3 million tons of plastic waste every year, and we have done several pilots in Vietnam, starting with the biggest paper recycling facility located in the south of Vietnam along the Mekong River. It produces more than 600,000 tons of paper, and it's only taking used paper and recycle it. You don't use trees in Southeast Asia, you use used papers. And used paper contain laminated plastic. And that causes a problem, as you can see here, and it ends up being more than 60,000 tons of plastic is just generated from this plant only, and it goes to the dump site. And you remember what I mentioned, if plastic ends in the dump site, it degrades, enter into the groundwater, river, and sooner or later in the ocean. So we have to stop that leaching. And we took a nearby cement plant, as you can see, not so far away from the Mekong River, and we took dried plastic waste from that paper recycling and used it as a co-fuel in this cement production plant. A little bit lower feeding rates that we saw from China, but anyhow. And here again, this represent many, many measurements of dioxin emissions. And I just repeat, you remember the professor claiming that if you feed plastic waste to cement kilns, you will automatically create dioxins. You see the solid arrow represents 0.1 TEQ per noble cubic meter, international most stringent standard, easily. I mean, far below. And no difference between using coal only, and that is very important. I mean, they are reducing the coal consumption and adding plastic waste feeding, but no influence on the dioxins. Only this plant will then take more than 100,000 tons of these plastic streams every year, and it will avoid releasing at least 10,000 tons of plastic to the sea and save at least the same amount of coal. Again, a win-win story. In our project, we work with UNEP, UNDP, etc., around in all these countries, and they do a lot of recycling activities, MRF producing pre-treatment plants, etc. And as this is a typical what happens in a recycling facility. A lot of that plastic waste is non-recyclable, and it's usually dumped. And here you see from a typical recycling village. Here you see trucks are coming. They are really, really huge, and they are coming continuously. Delivering plastic waste. They even sometimes import plastic waste and give it to the recycling facilities, and the recycling facilities are producing a lot of non-recyclable plastic waste. This is a road, was a road. It's closed by plastic waste, and it's really, really bad, I would say. So here you see on the left, you see a guy in a typical recycling facility, and on the left side, we are seeing a typical plastic waste feeding facility using a cement kiln, which we were using in this context. I will show you the cement plant. So it's a little bit different. This is the plant that we were testing only some weeks ago. And here you see the plastic is fed into the cement kiln. We don't have any results yet, but as you can see, we are always hiring independent certified companies which are qualified to do emission sampling and to make sure that they measure dioxins and all other air pollutants, of course, in a sufficient and responsible way. Then we go to India. They produce close to 10 million tons of plastic waste. We have done several tests in India, and this is showing you a dump site mining activity. This is from Nagpur, one of the biggest cities in the midst of India. And here you see some typical photos of the plastic fraction, which are taken out of the dump site. They are taking out all kinds of valuable materials like aluminum cans, metals, plastic, fibers, etc., paper, and it's used in the production of cement and replaces fossil fuel. And here you see from a typical waste pre-treatment plant for waste in a typical cement plant. They receive the waste and they pre-treat it, they dry it, they shred it, they homogenize it, they make sure that it's satisfactory for the cement production, and to make sure that it doesn't harm the emissions, of course. And here again you see some of the figures from the emission studies. As you can see, far, far below the most stringent emission limit value for dioxins. I can just mention that in India they have 2,200 dump sites in more than 7,500 hectares of land. And there is a big activity going on now in India where they want to clean up all the land and to remove all the legacy waste and to get rid of it, because it's much, much more worth as a clean area and green area for property, for parks, whatever. So there's a big activity going on in India, and this is going to be repeated elsewhere in the world. Okay, go to Thailand. They produce more than 3 million tons of plastic waste. And I will show you one dump site that we cleaned up. We have been active in several dump sites in Thailand, and we have also investigated what is the leaching from these dump sites. We have been digging profiles into all dump sites which are 10, 20 years old, and we see how it breaks down, exactly what I told you, and how it leaches into the groundwater and ends in the river. Always in the nearby river you can find large amount of microplastic coming from these hidden dump sites. This shows you some of the composition of a typical dump site, and I will not go into the details, of course. Just show you. Thailand is one of the highest plastic consumers in the world, and the Thai dump sites contain between 40 and 80% plastic waste. It's incredible. They have 2,500 dump sites in Thailand, and we have estimated that these dump sites contain close to 200 million tons of plastic waste. And usually it looks like this. If not, it's segregated, taken up by the cement industry, and I have to emphasize this is done by the cement industry. It's the initiative of the cement industry. They start the cleaning activities. They put equipment there, manpower, etc., and they segregate the waste, sell the different fractions to different, and take what is possible, for example, the plastic waste, and use it as a co-fuel in their cement production. And here we can see a typical co-fuel plastic waste. And this is the cement plant in Saraburi. And here we can see from the exit stack measurements again. We even do, ambient air sampling around the cement plants to make sure that there is no load of other pollutants or even dioxins in the nearby vicinity of the cement production sites. And we have never identified any elevated emissions. And here again you see some of the figures. I will not go into the details. So it means that again, this particular cement plant will remove huge amount. They have a capacity of taking at least 250,000 tons of plastic waste every year, and to make sure that it doesn't end up in the Thai Bay of Thailand. In our project, we have conducted 9 pilot demonstrations so far, And we have tested several types of large volume non-recyclable plastic waste in 4 countries. And has shown that it's technical and environmental feasible and acceptable, and also shown that the emissions of all air pollutants, also dioxins, are unaffected by plastic waste feeding. These 9 cement plants, and we are talking about thousands of cement plants around the world, of course, only these 9 cement plants will be able to remove much more than 100,000 tons of plastic waste every year and save the same amount of coal, which is a win-win story in my world. Also very important, I introduced to you in the beginning of my presentation that especially non-recyclable plastic waste contain a lot of hazardous chemicals, and these are safely destroyed in the high temperature environment inside a cement rotary kiln very effectively. This is just a curiosity, but it shows you, it tries to in a way compare a cement kiln co-processing option with a typical waste to energy incinerator, which is very popular in Asia today. Everyone wants to build an incinerator. I can just mention to you, it's very expensive to build and also to operate and maintain. It has a very low energy efficiency, usually maximum 25%, compared to co-processing, which is between maybe 90-something% effective. And very important, the electricity production will never actually be able to recover the cost of building such a plant. We have never seen that anywhere. And very important, when you burn plastic waste and waste in an incinerator, you will end up having 20-30% of residues, slag, air, flue gas residues, etc., fly ash, which needs to be disposed on a dump site or landfill anyway. That's not the case with co-processing. And also important, most of the Southeast Asian countries that we are working in, they have a long rainy season and making efficient burning of waste very difficult. You know how to burn wet waste. It's not easy. And you will create a lot of dioxins, I can assure you. Yeah, and also very important, I mean, now in India, they are talking about building 100 new incinerators. They already have in operation cement industry, which are operating daily, you know, 24/7. Why not try to use some of these instead of building 100 new emission points? For me, that is not logic anyway. Okay, I will wrap up. In our project, we conduct a lot of workshops, capacity building with governments, with industry, etc. We organize a lot of big meetings. We had a regional forum in Bangkok last year. We have workshops everywhere. We was in Bhutan not so long time ago and training the government of Bhutan and in many conferences. We have written several books, book chapters, and a lot of papers, articles. This is only a few of them, and you can find it on our webpage if you are interested. I will just wrap up. Microplastic and plastic chemicals pose an imminent threat to human health, marine ecosystems, and biodiversity, and this issue cannot be solved through recycling alone, as we have seen, and we see it more and more. The accumulated billions of tons of plastic waste form a looming crisis requiring urgent attention. To avert an environmental disaster, it's crucial to implement a large-scale treatment solution for non-recyclable plastic waste. Co-processing in the cement industry, a well-regulated and cost-effective method available worldwide, stands out as the only viable option capable of permanently eliminating significant quantities of plastic waste, as well as safely destroying the hazardous chemicals. Additionally, it offers the simultaneous benefit of substantial coal savings and reduction of greenhouse gas emissions. So in my world, that's a win-win opportunity, and it's practical, and it's affordable, and it's possible for everyone to implement if they are interested. You can find a lot of literature, updates, etc. on our webpage. And by that, I will thank you for your attention. Thank you.
Thank you, Corey. I don't know what else I can say after such a presentation, and I will do something a little bit special here. I will also say a few sentences in French because we have a rather big audience from colleagues from de l'Afrique francophone. Donc je vais dire quelques mots pour les collègues pour qui j'étais en train de traduire tout à l'heure. So I will try to speak in both languages. I have not done that often, but that should be not too difficult. I just want to say a few words, and I introduced this at the beginning. I said this is a big part of our roadmap, of the GCCA roadmap. Donc c'est une partie importante de la feuille de route de l'Association globale du ciment et du béton. L'efficacité énergétique et la substitution des fuels fossiles par l'utilisation de déchets, les plastiques. So by recovering plastic and the energy from plastic waste, but also all other kind of societal waste, but also waste from other industries. And currently, the alternative fuel substitution rate globally, we saw the example of Norway where it was 75%, but actually, currently in average globally, it's 6%. So we still have really big capacity. Donc le taux de substitution actuel de l'industrie cimentière en moyenne globale est seulement de 6%. Or, on a entendu l'exemple norvégien où ils sont à 75%. On a d'ailleurs aussi des usines en Allemagne qui sont à 100% de substitution. Donc, il y a un potentiel énorme. And we also heard from Corey that there are billions of millions of tons available of plastic. I think there is enough to substitute coal for several decades, I think, Corey. Donc, on a des stocks de plastique dans l'environnement qui peuvent couvrir les besoins énergétiques de l'industrie cimentière pour encore plusieurs décades. So, here you see our current substitution rate. I mentioned it. You also see that this contributes to reducing our CO2 emission. And currently we don't have statistics on plastics only. So the statistics we have on plastics are still mixed with refuse-derived fuels. But this is something we are trying now to lay down is how much plastic is recycled. Donc ça, ce sont nos statistiques. Pour le moment, on n'a pas de statistiques sur le plastique pur parce que souvent il est mélangé à d'autres déchets. Mais la boîte RDF, en ce compris les plastiques, c'est quand même 41% de la substitution. So the last thing I wanted to say is an extract from another UNEP report, which was released just before the plastic treaty negotiation, which was called Turning Off the Tap. That report actually speaks of more than 100 million metric tons, so we are slightly changing units here, but it's still a lot for short-lived products that need a disposal solution by 2040. So what even this report says is that in addition to what is in the environment, we still have a lot of plastics that will have to be dealt with from what we will produce currently. Donc ce que le rapport ici dit, c'est que on va se retrouver avec plus de 100 millions de tonnes métriques de plastique, de produits qui à courte durée de vie, et donc il faut à tout prix une solution. Et en fait, ce que ce rapport dit, c'est que les fours de cimenterie, donc l'UNEP le dit et a analysé, qu'on a un four de cimenterie dans quasiment chaque pays du monde, et que donc c'est une option facile dans les pays en voie de développement notamment. Au lieu de construire des capacités d'incinération, bien, utilisons les fours de cimenterie qui sont là. So what the UNEP report says is that it's recommended to use the existing cement capacity that anyway needs to be fueled and use them to deal with all those waste plastics. No. So now what we are saying at GCCA, we still need the enabling policies, and I think that's a key point also of what we saw from Kari's presentation is that we need the enabling policies for the collection and the treatment of the waste and make sure that there is legislation in place to make sure that countries have the infrastructure, because what we see is that it's the infrastructure for the management, treatment infrastructure that is missing. Donc il faut qu'on ait l'infrastructure et les législations pour empêcher la mise en décharge et la production de déchets résiduels, et aussi de donner l'importance ou la priorité qu'il faut au traitement des déchets. So I don't think I will be much longer because I can say we have our members, maybe that's important to note, is that the GCCA members are committed to sustainability as an industry. We have heard from Corey that we are not producing more dangerous substances by co-processing waste, but still we have to be sure we do this in the right way. And so as the GCCA, we have produced guidance and guidelines for our members with negative list of waste that cannot be used, and with what are the measure and the control measure that need to be put in place to carefully select the waste and to make sure that we do the appropriate monitoring to process the waste. Donc ce que j'explique, c'est que la GCCA a en fait développé des règles de bonne pratique pour faire en sorte que nos membres aient toute l'information nécessaire pour assurer que le co-processing des déchets se fasse dans les conditions optimum, pour être bien sûr qu'effectivement il n'y ait pas d'émissions supplémentaires qui soient générées. So we have produced checklists for our members and good practices to do this in a good way. And of course we can also discuss this with policymakers if you are interested to develop this in your own country. So that's the end of my own presentation, and I will now pass the floor to, what am I doing here? And Andriana, who I will reintroduce because we have a lot of new people in the room. So Andriana is the lead waste from the Climate Champion, and you will talk to us now about ending open waste burning. We saw some picture from Corey, but floor is yours and you have no slides, so we can only listen. And if you don't mind, I will go in the back of the room to do simultaneous translation for our colleague francophone.
Thank you very much. Good afternoon. I'm always really impressed by the multilingual people, but all I can offer is to speak English, Swahili, and even that is, debatable if I can talk about cement or open waste burning in Swahili, and my mother tongue, Kamba. So unfortunately, I don't think, apart from Michael, who speaks Swahili, there's nobody who speaks Kamba. So I guess I'll stay with English, but I'll try and take it slow so that we can all follow each other. Before I start, I would like to acknowledge members of the multi-stakeholder partnership that I'm talking about this afternoon that I see in the audience, including Mr. Mbasi and actually Mr. Michael as well. So at the very beginning, I want to take you back to COP26 in Glasgow. It was the first time that open waste burning actually came on the agenda, the COP agenda. And at the time, we had partners that are in this room, and also including International Solid Waste Association, Climate and Clean Air Coalition, and Engineering X. I'm seconded from Engineering X. Engineering X is Lloyd's Register Foundation, together with the Royal Academy of Engineering. And together, those two institutions seconded me to the high-level champions, the climate champions. And in case you're wondering who are the climate champions, we are here championing the end to the threats that we experience from climate change. Climate champions work at the same time with the COP presidency. So while the COP presidency works with the state members, the climate champions are appointed by the different country hosts, and they work with bringing state and non-state actors through the Marrakesh Partnership. So preceding this COP event in Glasgow, we had a global scanning that was conducted by the Safer End to Engineering Life, which is a program within Engineering X. And this global scanning was experts from around the world. They wanted to find out what are the things in this world that are considered a safety threat to human beings. And this, they looked at the importance of safety, livelihoods, and actually they found waste management is one of those things that happen in our lives that is a threat to life. And they realize they have to prioritize tackling waste mismanagement. Now, here's the thing that I want to, and it was really good to watch this presentation at first, is to remember that open waste burning is actually practiced everywhere in the world. So that includes developing countries and developed countries. As you have seen, of course, the practice is more significant in developing countries. In Africa, you have to think that about 90% of the waste that is actually produced from our households and all the other sectors ends up openly dumped and most likely burned. Now, why open waste burning? Actually, we have already heard the different effects of waste mismanagement, plastic waste mismanagement from the previous speaker. But I want to speak to you, as he was talking about, I was noticing soil pollution, air pollution, water pollution that comes from waste mismanagement. There's also health impacts, which he touched on. Millions of deaths per year, and you have to think some of the illnesses caused and the premature deaths, and in some of the most marginalized communities. And it's happening more where children and women are concerned, youth who also work on those dump sites. Waste is also a challenge for climate change. So I was listening very keenly when you talked about the concrete sector is responsible for about 7%, and you're moving towards net zero. Waste is something that has a fuzzy figure. So I've heard anything from 4% to about 10 to 12% of greenhouse gases come from waste mismanagement. But also you have to think about short-lived climate pollutants. If we want to get to the goal that we're negotiating here to get to 1.5 degrees, we need to take action not only on long-lived greenhouse gases, but also short-lived climate pollutants, such as the ones that also the previous speaker spoke about, methane, and essentially also black carbon. So waste contributes significantly to that. And also, of course, the waste management and the few services that we have in Africa, for example, are conducted from the informal sector. That means we have the safety and livelihoods of millions of marginalized communities that are dealing with waste. And you can read this from the report that we put together, which is called the Open Waste Burning Report from 2022. And we chose to look at the challenges and opportunities, because I think I can spend another half hour talking about the challenges. But really sometimes we have to ask, but where are the opportunities? And I like the fact the previous speakers also looked primarily at the opportunities. Now, when we had that initial session at COP26, myself and Professor Desta started to work on the Open Waste Burning Initiative. And this was actually very well received, because at AMSEN, in AMSEN 18 in 2022, we worked with all our partners to ensure that all environment ministers endorsed the elimination of open waste burning, committed to the elimination of open waste burning by the year 2040. But, you know, we like to pledge, but sometimes you have to ask yourself, how do you meet that pledge? So the ministers, in addition to supporting that, they chose to actually also support a vehicle, the multi-stakeholder partnership, acknowledging not one institution, not one group, not one country can do this can go at this alone. We need to have a partnership that realizes the elimination of open waste burning. Now, and this partnership became active at COP27 in Sharm el-Sheikh in Egypt, where our partners UCLG Africa hosted us to ensure that we have realized the launch of the multi-stakeholder partnership. And in doing this, we ensured that our partners came on that day, and from that onwards supported the multi-stakeholder partnership, including where we are here, GCCA. So just to name our partners, it's Engineering X, Climate Champions, UCLG Africa, Climate and Clean Air Coalition, ICLEI Africa, Stockholm Environment Institute, Practical Action, GAIO, which is the Green Africa Youth Organization, GCCA, Airtel. And we hope that in presenting these challenges here, we also call on partnership from those who are in the room that are not yet partners. Now, the progress of the partnership has been one that is going to lead us to 2040 and beyond. In fact, if you look at why we should have this partnership and why we have many different institutions joining us, is because it's looking at improving air pollution, soil pollution, water pollution. It is looking at creating jobs and protecting livelihoods, sustainable livelihoods, saving lives, reducing carbon emissions, and working in a way that leaves no one behind. Now, why partnership actually is something that is attractive for us in the way of working? Because even as I have said, open waste banning affects everyone. But we have agreed that it's an effect that is disproportionate for some groups, specifically marginalized communities. The informal sector, people who live near waste dumps, women and children, youth and young women and men. But I think what we ought to remember as well is that when this waste is burned and it gets in the air, it travels, it's deposited, the waste, the sediments from that is deposited, it goes into the soil. So a lot of us who live in places that we think they don't affect us because we don't live in these poor communities, most likely even you breathe polluted air and you are affected by waste burning. So we are working and we are calling on you to work with us to secure strong political commitment at national and local levels. And this way we have actually got very good milestones and accomplishment. Now we are showcasing what a multi-stakeholder partnership can look like with working with UCLG Africa and the African Ministerial Conference for Environment. But we are also calling for individual governments to champion the elimination of open waste burning by the year 2040. We also want to ensure we elevate sustainable and inclusive waste management, and we elevate this into the political arena, the policy arena, but also as we are asking for financial commitments to implement what we are pledging here once again to do, we want also waste management and circularity to be at the global highest agenda, as much as we are domesticating that in our local agendas too. But as we have heard, and it's very impressive to see these data gaps that are being filled with the work that you're doing in South Asia, we are also calling for a way to bridge data and information gap, as well as investment and financing gaps, which are already found in the elimination of open waste burning and ensuring that we have circularity that is mainstreamed. Partnerships, we're also calling for partnerships to amplify best practices. Now, as much as it's a really bad practice to burn waste openly, there are also best practices that are already in our cities, our local governments, and our local communities. How can we ensure that we amplify those best practices? Now, I was at the ISWA, which is the Waste and Resources Pavilion upstairs, and it's the first time coming from COP26, given where we have started to where we are, where we actually have a Waste and Resources Pavilion for the first time in a COP. And I liked what Aditi, who was moderating our session previously, said. Often we do ourselves disservice. We talk about informal communities or informal business, and in doing so, we ensure that they never have access to the kind of financing we do. So I recommend a change in languaging and framing. So Aditi at the time, and I told her I was going to borrow this. So instead of talking about informal waste sector, how about you talk about micro communal enterprises? Wouldn't that sound like something you can invest in, right? So I think we need to change the language. We need to acknowledge it's an essential service that is provided by the informal sector. And those businesses are in place. They do waste recovery, waste recycling. For Africa, the average of waste recycling is about 10%. Most of that is done by the informal sector. So we need to find ways to enhance opportunities for circular economy. I like also what the previous speaker said, because Africa is awash with proposals for the waste to energy projects. For some reason, it is beloved. And I can see why. We have a problem with energy security. We have energy poverty. And in that, we also have a problem with food security. Waste is something that actually overlaps in both of those sectors. So I can understand why Africa would look at a way to ensure that we have more energy available at household level and for other sectors too. But however, if there is no one project for waste to energy that has been profitable, that is sustainable, why are we still going that way? Are we not talking the same language? And I think it's quite impressive that GCCA and partners have gone the way of ensuring these pilots are conducted in a scientific way, so that there can be no question and pushback from that. And I call on this so that the next time we meet, we have an idea of also what's happening in Africa. Because as much as you have the pilots in South Asia, when you meet with our policymakers, they will ask you, where are the pilots in Africa? Because they too want to see what is happening, that is happening within economies that they understand, within communities they understand too. So in conclusion, I want to tell you that we acknowledge from the very beginning, given the milestones we've had, all African environment ministers, through the presentation of UCLG Africa, having all those local governments and city and municipalities, we are still saying that we know we cannot go at this alone. We need to go forward with you. So we are calling on you to work with us in this multi-stakeholder partnership to eliminate open waste banning. And we have actually 5 areas that I would encourage for you to look at. The first one, and he also addressed this, governance and the enabling environment for the kind of projects that you're doing. This is a different scale. At the global scale, for example, you have heard about the resolution for plastic that is looking at a global level. At the regional level, we have said the African environment ministers support this resolution to eliminate open waste banning. And because of that, we had our first report back to the ministers where we presented the pilot projects that are ongoing in Africa. And again, once we will have that environment ministry meeting in 2 years' time or 1 year's time, then they will expect another report back on what our progress is. And that means within the governance framework, we are embedded in perpetuity. So it's not a once-off, it is something that we do every year to ensure that we eliminate open waste banning. Finance. We need financial models that understand our peculiarity where waste management is concerned. Not ones that look at that gap and then say that they cannot deal with it because it is too complicated. It is too important to ignore. But we also need to talk to our governments and our governance frameworks to look at ways to identify incentives. How nice to have the carrot instead of the stick. I think it is always important to remember that the carrot is better than the stick. Then we also want to ensure that we have community and people-centered approach. And that is why Engineering X, through the Lloyd's Register Foundation and Royal Academy of Engineering, took this on, because we need to have a people-centered approach. We also need to have inclusive technology. It is amazing the kind of innovation that we have on the continent, including applications, technology to ensure that we have that baseline data that is much needed so that we can inform and underpin policy making and investment. But most of all, we want you to be ambassadors to share best practices and amplify the best practices that we have so far in Africa. So let's continue talking about solutions, not just the challenges. Thank you very much.
No, I had a microphone somewhere. Yes, here. Is it work? Yeah, it's working now. Thank you. Thank you, Cory. Thank you, Andreana. I think many people have left, but I'm sure we have really interested people here. Any question or any comment? And Brigitte, I see in your eyes you want to comment. No? Yes?
Not necessarily, but I just really wanted to thank the speakers for their intervention. I was, of course, very attentive, and particularly to what you say, because we would like to push as well to increase the usage of waste in certain areas. So I'm sure that we will have a developing conversation together, and maybe with the audience behind. So.
My name is Jean-Pierre Elongbasi. I'm the Secretary General of the United Cities and Local Government of Africa. I'm a member of the partnership. And I want to state what I said when we were establishing this partnership. For us, cities, mayors, governors of provinces, waste is the barometer of our performance. If you come to a city, they rate your capacity to manage your city through the cleanliness of your city. If your city is not clean, the management is not clean. If your city is clean, it means this city is managed. So for us, it is very critical that we treat this issue very seriously. And it's not a technical issue. For us, it's a political issue. And politics go hand in hand with money. So what we see is that this sector is not well financed. The cost of treating waste is not commensurate with the capacity of people to pay the allowance for waste. And this is why we like a collaboration with the concrete, because you are showing a sort of way of transforming waste into an asset. And this is very clear that through this collaboration, not only we treat a political problem of ours, but we also address the financing of this sector. And we also have a direction towards a better planning of the management of waste in our cities. But sometimes we are told that our waste is so organic that the combustion capacity of this waste is not good. So I don't know. I'm asking this because you propose that we use concrete and equipment to sort of get rid of some aspect of managing the waste. But what about the quality of our waste compared to what you are proposing?
Kari, you want to answer that one?
Okay, it's a difficult one in some way, but also easy. I mean, co-processing is not a universal waste management or treatment tool. And of course, if you have a lot of organic waste, there are many other options prior to co-processing in the cement industry, basically because it might be more available immediately locally as a manure, or as a fertilizer, or biogas, you know, for running buses, whatever. So highly organic waste might find very easy local solutions before you go to co-processing. Co-processing might come a little bit later.
Thank you. Any? Vous voulez poser une question? On peut la traduire. Vous n'avez pas compris. Je pense que Jean-Pierre parle français, mais je ne vais pas lui demander de répéter en français. Je vais laisser nos collègues poser la question.
Bonjour à tout le monde. Oui, ma question est celle-ci. Quand on regarde au niveau du développement durable, les économiques, eux, ils cherchent à gagner de l'argent, bien sûr, en dépensant moins. Alors ma question est celle-ci. Est-ce que ces usines de cimenterie vont-ils... qu'est-ce qui serait plus avantageux pour eux? Utiliser le charbon comme source d'énergie ou soit utiliser les déchets? Parce que si les déchets leur demandent beaucoup plus de ressources, je crois qu'ils ne vont pas militer pour l'option utiliser les déchets par rapport au charbon. Bon, c'est un peu ça ma question.
Okay, I will translate for everyone. I will try to translate. So the question is from an economical perspective. What's the best for the cement industry? Is it to burn coal or waste? Because if it costs a lot of money to prepare the waste, then maybe the industry will stay with coal. So that's the question. I don't know who wants to answer. Me, okay. So I will answer in English first, but what I would say, it's there are many parameters in there, and this is where probably, and as well in the context of the plastic treaty, we are looking at extended producer responsibility scheme, because this is typically something that could also help to cover the cost. So you have different things. You have the cost of processing the waste, and coal is expensive, of course, so plastic is not. But you have all the upstream activities of collecting and pre-processing and treating that are costly activity, and where the cement industry says as well, why should we bear that cost, right? We already have the cost of treatment, but we shouldn't bear the cost of treating, processing, and pre-processing. So this is where, again, collaboration will be answer, and we need a whole value chain here to manage the waste. And this is where, as you said, cities have a key role to play, and regional governments, and this is where we need also the policies to ensure that it's not less expensive to dump the waste, and that we make sure that then the waste are in an organized system brought to the industry. And there we have economics in the world situation. But EPR is probably the answer to those questions, and good and enabling policies. And I know my friend has translated. This is amazing now.
And maybe to add that we want to phase out fossil fuel, and especially coal, as soon as possible. And we have seen, for example, in Southeast Asia, that the increase of coal prices has increased by 5 times during the last few years. And this is probably going to continue, while waste seems to be a lot.
Jean-Pierre.
Yeah, but what is the timeline for that? Because if at all we are serious with dealing with plastic, what will be the timeline, the deadline of plastic phasing out, and then the cement industry caught into an alternative to be found?
You have no answer, but you know how many years of plastic we have in the environment.
We will have enough plastic in the environment for in the foreseeable future. No, I hope that we are able to, scale up and move much faster on phasing out fossil fuel like coal, of course. But I'm as open-minded as you, and I really cannot give you a good answer when it will happen, unfortunately.
And one more question?
Yeah, thank you. Thank you so much. So my name is Michael Koech. I work for Airtel Africa as an environment and social lead for the group. And thank you so much for the insightful presentations. As Dr. Adriana had introduced me earlier, we are in the same partnership, the multi-stakeholder partnership on open waste burning, and really excited to be here. So I think now that I know her, I would want to ask I would want to ask one question. So you've given us a good presentation on the technology that is used to burn plastics and generally waste from what I saw on the pictures. What I was wondering is, for a developing world, region or country like ours, the equipment, from the look of it, looks very expensive. So what kind of measures or initiatives do you have for that technology transfer first, and also to reduce the cost of installing such a plant for energy generation?
Well, you don't build a cement plant to get rid of waste. It's the other way around. You have a cement plant already in place. Either you have it or you don't have it, but you never build a cement plant to start to treat waste. So in most countries in the world, you have cement production in cement plants, and if you have, and if it's feasible and technical feasible and environmentally sound, then you can consider to use co-processing in that plant. So you need a cement plant first. Needs to be in place. You cannot build a cement plant to start treating waste.
And I like to say there is almost a cement plant in every country in the world.
So I guess a follow-up to Michael. So if I look at your list of partners or members for GCCA, I see some of the African ones, including Dangote. I guess the question is, will each of these facilities have a cement kiln that burns at 2,000 degrees Celsius to be used for the co-processing of plastic?
I will start the answer and I will pass on to you. The answer is yes, and we actually initiated with OPTOCE a mapping of our members in Africa and the rivers in Africa and the dump sites in Africa. And now I will pass on to Cory, because I think it's your dream to do an OPTOCE Africa.
Sure. Yes, we have been investigating Africa and other countries as well. So there is a huge interest, in fact, to be part of our project. So I hope that we will move into Africa. You know, there are different technologies for producing cement, and not every cement kiln is similar. And you need to do a local feasibility study on the technical issues before you can judge if co-processing is a suitable option or not. There are, you know, old, outdated technologies which are still in use. I cannot pinpoint any specific country at the time being, but there are, you know, to follow up on that, there are technology which should not be used for co-processing of waste and replacing fossil fuel. But that will always be investigated in a kind of technical feasibility study.
Thank you. Well, I think that many people still want to continue the conversation, and actually it would be nice if you were able to do this here, not publicly, but I would like to call for a group picture, because I think we have an amazing, it's really great to have Jean-Pierre here with Andriana and Cory, and maybe we come to take a group picture here or outside. Yeah, because it's our partnership on two partnerships here. So I think it's good. It's OPTOCE, open-ending waste, and our partnership with UCLG. So many partnerships here.